Hey guys, I hope you're ready for some more fun with math and Pythagorean identities. So, what you'll see here is I have written four quadrants. So I will label x, and this is my cosine theta. Y is sine of theta. And then I have these little ASTC. And you've seen this before, but I just want to go through and talk about what it means one more time. So when we're working with the unit circle, and you can kind of see that I've put, oops, the unit circle over here on the side. It's a radius of 1. And then as I drag this point around, values change. So if we're using the x is cosine, y is sine type situation, look at how my x and my y are both positive here, cosine and sine. And if cosine and sine are both positive, that means tangent must be positive too. So in quadrant 1, all trigonometric functions are positive, all positive. When I come to quadrant 2, x is cosine. Notice how cosine now is negative. So x is cosine, y is sine, sine is positive. This will mean tangent's negative because a positive divided by a negative is still a negative. All right. Hopping down here, we've got two items negative, sine and cosine, which means when I do a negative divided by a negative for tangent, that's the only item that is going to be positive. So I don't know what's happening here. I'll get rid of him. So tangent is going to be positive, okay, because you have those guys both negative. Last but not least, when I swoop over this way, x is cosine, y is sine. My cosine is positive. Sine and tangent are not. So there's like an acronym that can be used to go if you go counterclockwise on your unit circle. All students take calculus, you would have seen. One of my favorites is anteater slurp, tiny creatures. It just is, fun. And if I knew how to draw an anteater, oh, hey, this is a nice anteater to draw his little tongue and his eyes. And then I don't know if they have ears, but oh boy, I shouldn't have drawn that smiley face. But oh, now he has no body. But that is kind of why this works. Anteater, slurp, tiny creatures. All students take calculus. Whatever you need to remember this by. Last but not least, and we'll be talking about this, but you'll see at the unit circle when you reach these. Like the axes, sine and cosine have special values. And that also corresponds, guys, to the graphs of sine and cosine. And we will talk about that in the next video. Last but not least, I do want to just show you kind of like an application here. Can we label this, please, 0? This is my 90 degrees, or pi over 2. Over here is pi, and then this is 3 pi over 2. These numbers are important for you to remember, okay? Um, if you remember pi is equal to 180, that's good. The other thing you can think about if you struggle remembering the pi over 2 and the 3 pi over 2 here, guys, is it's counting by pi over 2's, right? You're going up by halvesies. So that's nice. Last but not least, say I gave you this. Sine of x equals, I don't know, negative 1 over the square root of 3. And pi is less than x, which is less than 3 pi over 2. Find cosine. Okay, so what this is telling us, guys, is we can still use our Pythagorean identity, sine squared theta plus cos squared theta is equal to 1. So my sine is negative 1 over rad 3. I don't know what my cosine is, but it is equal to 1. Let's see. Oops, forgot the squared. Negative 1 over rad 3 squared is 1/3 plus cosine squared theta. I'm going to write a smart version of 1, which is 3 over 3. So solving for cosine squared, oops, not 3, yeah, 3 over 3. I'm going to get cosine theta is equal to plus or minus the square root of 2 over 3. We could go through and like rationalize this. And it just depends on like how the question is asked, if it's necessary, but it is important for you to understand that all of these items are equivalent. So I can multiply by rad 3 over 3. So this would give me rad 6 over 3. So all of these are equivalent. It doesn't matter which one you choose as your final answer. This one's fine. But I do need to select the sign. And again, my hint that it's giving me is right here. X is between pi and 3 pi over 2, meaning it is in quadrant 3. The only thing that's positive in quadrant 3 is tangent, so my cosine will be negative. So I'm going to select the negative version for my answer. So when you have these little restrictions and you see these signs, you just want to double check what quadrant you're in. All right, that was fun. I hope you enjoyed it as much as I did.